Hey guys, so here we are with 7.3. Like 7.2, we're talking about parallelogram that's much like that. We're going to be kind of doing the opposite almost as what 7.2 is doing. So here we are proving that a quadrilateral is a parallelogram with those kind of theorems that we were looking at in 7.2. So we're going to be using what's called the converse, which would be like the reverse or the opposite of those theorems. Alright, so before we get started, let's do a little comic strip here. This is in the bleachers. So this looks like a soccer field here. I'm going to bend your knee. If it hurts, I want you to scrunch up your face in agony and let out a bloody curl scream. Blood curling scream. So I always think that one's funny. I always love the in the bleachers. Alright, so as we go into our theorems, like I said, it's the converse, so we're looking at this pretty much the same theorems as before. So here's our parallelogram opposites theorem, where the opposite sides are congruent and the opposite angles are congruent. So you have one for sides and one for angles. So that would tell you that a quadrilateral is a parallelogram. So if you have a four-sided figure and you have this situation where you know opposite sides are congruent, both pairs, then you know it's a parallelogram, or opposite angles, both pairs, then it would be definitely a parallelogram. Okay, so right there on page 207 in your notes, underneath these theorems, there's some little places for notes. You can just go right underneath this one here and write this down. Number one, we're going to write this one down in that little note section. In quadrilateral W, X, Y, Z, the measure of angle W is 42 degrees, the measure of X is 138 degrees, and the measure of Y is equal to 42 degrees. Find the measure of angle Z. Is WXYZ a parallelogram? And then explain your reasoning. So that's what we want to do here. So the first thing we might want to do is actually draw this parallelogram. So we can draw one out. So we have two opposite pairs of parallel sides. So we can draw a parallelogram. And let's go ahead and name it W. So we'll put W, X, Y, and Z. Label it around. Let's put down what we know. 42 is, W is 42. X is 138. And Y is also 42. And we're trying to figure out what Z is. So we know that in a quadrilateral, all the interior angles will equal 360 degrees. If you've forgotten that, you can do 4 minus 2 times 180. So that would give you 360. So if we add all these up, we will get 360 degrees. So let's go ahead and do that. So this will be like our X for right now. Our Z is going to be like our X. In fact, I'll just use Z instead. So if I say Z plus, let's add all this up here. So I got 42 plus 42 plus 138. And so that's 222. So 222, and that's all going to equal 360. And I just got to subtract 222 from both sides. I'll just do it on the calculator here. 360 minus 222, and we get 138. So Z is equal to 138. So that means that this one now is 138 that we can fill in. So the answer for Z, like they said, find the measure of Z. So the measure of angle Z is 138 degrees. And then the next question was, is it a parallelogram? Well, since opposite angles are congruent, it is a parallelogram. So we could say yes on this one, parallelogram. And the reason why, so we'll say because of this one right here, the I'll just put para opposite angles theorem. That's why. All right. Now here's an example from your book. Wants us to know, is this a parallelogram? Basically, an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. So you can kind of see what it's doing there. In the diagram, side AD and side BC represent 2 of the swinging arms. Okay, so we got the side AD, side BC right there, 2 of those swinging arms. And side DC is parallel to the ground. So DC here is going to be parallel to the ground, which is line L, parallel to the ground, line L down here. Explain why the moving platform AB up on top is always parallel to the ground. And so we can see that because this is a parallelogram, we can see opposite sides are congruent. Both pairs of opposite sides are congruent, 38 feet and 38 feet here, 16 and 16 over here. So because it's a parallelogram, that's why this is going to stay always parallel to DC. AB will stay parallel to DC, which will then also in turn stay parallel to the ground. If this one's parallel to this one, then they're all going to be parallel, and this one's parallel to here, then obviously transitive property would tell us that AB is going to be staying parallel to line L. So that's kind of what this is probably saying. Inside here, the shape of a quadrilateral ABCD changes as the moving platform swings around, but side lengths do not change. Both pairs of opposite sides are congruent, so that means it's a parallelogram because of that, like we talked about. By definition, these are parallel then because that's parallel to that one, and so on. So it's saying transitive property, just like I said. So that's why it's parallel to the ground. Hey, one more that's on your in your book. You can just kind of see this one here. I'll just put that one down so you can kind of see it and watch this one. It's going to be similar to one we probably have, but you have opposite sides. So for what values of x and y is this a parallelogram? So if we assume that it's a parallelogram, then opposite sides here would be congruent. We can set up equations here for finding x. That's what they're doing there to get 10. Plug that in here, so that's 17. So it means that y is 17. Okay, on page 208, we also have, well, you still have this one, opposite sides parallel and congruent theorem. So that's on there. I believe that's back on page 207. And then we also have the diagonal parallelograms, converse. So this is a new one. We didn't see this one in 7.2. So opposite sides parallel. So if it shows you opposite sides parallel and they're congruent as well, that's another way you can prove that it's a parallelogram. And then the diagonal one is that if they're diagonals in here and if those are bisecting each other, so if the diagonals of a quadrilateral bisect each other, then we can also say that that's a parallelogram. And that was the converse from the one that was in 7.2. Okay, so in the notes section here on page 208, so kind of at the top of 208, there's a notes section. Let's write down number 6 here. It says, for what value of x is quadrilateral MNPQ a parallelogram? So you're going to draw this parallelogram out, do your diagonals. This is 2x here, over here is 10 minus 3x, and those are congruent. So if these are congruent here, and we would assume that if these are congruent, that means it bisects. So we would just go ahead and assume that these two are going to be equal to each other. So we can just write out an equation now to show that. So we would just say 2x is equal to 10 minus 3x. And so we can add 3x to both sides. And so it's going to give us 5x is equal to 10, and then we just divide by the 5, and so x is equal to 2. So that's the value of x. So for what value of x is the quadrilateral a parallelogram? It would be 2, because that means that these two then would be exactly the same number, which would complete that one right here, the diagonal converse, the parallelogram's diagonal converse. Here's another one from the book. You got the doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TV. So if you look at the diagram, it's showing that ST and down here VU, those are both parallel and congruent. So according to this one right here, opposite sides parallel and congruent theorem, we can now say that this is a parallelogram. So that means that we conclude that side SV and side TU would be also congruent, they would be equal to each other. So that's what this is basically saying. You can read through that. Okay, so on page 209, starting with our extra practice, it says state which theorem you can use to show that the quadrilateral is a parallelogram. So number one, showing these two sides here are both parallel and the exact same letter. So that means that they would be congruent to each other. And so we would say that same one we just saw a second ago, that's the opposite sides parallel and congruent theorem. So that's number one. Number two, on this one they're showing us the angles, and both pairs of opposite angles are congruent. These are 19, these are 61. So that's the parallelogram opposite angles converse. So we do have one for sides, but this is one for angles. And then number three, this one's showing us diagonals in here that are getting bisected. So the diagonals are bisecting each other, and so that would be that parallelogram diagonals converse. Now we have to put the word converse in here because that's what it's saying to prove it. We're proving that this is a parallelogram with that. We're not saying it's a parallelogram and so that these are bisecting each other. No, it's the other way around. It's the reverse of that. Okay, time for a little quick joke of the day. What's a pirate's favorite food? Artichokes. Artichokes. I haven't had artichokes in a long time. I used to eat those when I was a kid. Okay, so number 4 on the extra practice is find the values of x and y that make the quadrilateral a parallelogram. Remember, the word quadrilateral just means a four-sided figure. And so in this case we have some expressions here. They're angles though, so opposite angles are congruent. So that would help us know something. So for this one we really need to remember back on 7.2. It's not actually in our theorems on 7.3, but it is the one from 7.2 that was saying that the consecutive angles, the ones here that are next to each other, are supplementary. These two can add up to 180. So really we need to take the 3x minus 20 and the x plus 40 and add that, and it will equal 180. So that's what we'll do here. So there's the 3x minus 20 plus x plus 40. It's equaling to 180. Solve this now for x. So we'll kind of combine like terms first. That'll give us a 4x plus 20 equal to 180. We'll subtract that 20 from both sides. And so now that would give us 4x is equal to 160. And then we just divide both sides by 4. And now we can see x is going to equal 40. So if x equals 40, now we can kind of plug that back in up in here where we see the 3x. To find the y, we can say, okay, this is 40, so 3x times 40 minus 20 will give us this one, and then those two can equal each other. So that's kind of what we're doing there. So we say 3x minus 20 is equal to 4y. And we're going to plug in 40 right there. So that's going to make that 120. So 3 times 40 is 120 minus 20. And then we're just going to kind of combine these two together. So that's going to give us 100. So 100 is equal to 4y. Divide both sides by 4. And 100 divided by 4 gives us 25. So that's what our y would equal. On number 5, so this is a really thin quadrilateral. It is 4 sides though, you can see. But it's showing inside here diagonals. There's a very long diagonal here and a little short diagonal here. So these are diagonals. Well, we would use those diagonals, set them equal to each other to prove that that this quadrilateral is a parallelogram. That's what we want to do to find the values of x and y. So if we look at, we could start with the y's, or we could start with the x's. It doesn't matter. I'll just start with x's. So 6x, this side, will equal the 4x plus 10 on this side. So remember, these are bisecting each other, so that means both sides will equal each other of that diagonal. So we'll start with, actually no, I'm starting with the y. Sorry, I thought I was starting with x's. So we'll do the y. So we're starting here at these two. So 2y is going to equal y plus 1 right there. So we subtract y from both sides. 2y minus y will give us a y, and that's just going to equal 1. So that was actually a really fast one. That's probably why I started with that one. And then the other one's a 6x. is equal to 4x plus 10. Subtract 4x from both sides. That will give us a 2x is equal to 10, and then just divide by 2, and so x is equal to 5. Okay, so 2 more just the same. So on number 6, we have the opposite sides here are parallel. These sides are parallel, and we would say, okay, they're going to be congruent. So already we can see the opposite. If this is a parallelogram, opposite angles are congruent. So we know that y has got to be 106 degrees. That's right away we could see that. That's what y equals. And then the x's, we'll set these two equal to each other to find out what x is, because opposite sides would also be congruent. So the 10x plus 7 is equal to 12x minus 9, and we'll subtract 10 from both sides to get the x's together. So we'll see 7 is equal to 2x minus 9. We'll add 9 now to get the numbers together on the left side. So it gives us 16 is equal to 2x. And then just divide by 2. And so 16 divided by 2 would give you 8. So x is equal to 8. Number 7, we would just set this up as opposite sides are congruent. So we could start with the x's, or we could start with the y's. So I think I'm starting with x's on this one. So yeah, so we'll set these equal to each other. 5x plus 16 is equal to 6x minus 1. Again, just solving in this equation. I'll subtract 5x from both sides to get the x's by themselves over here. So it'll be 16 is equal to x minus 1, and then just add 1 to both sides. So x then will just equal 17. So x is 17. And then this one here, 4y plus 2 is going to equal 70. Subtract 2 from both sides to get the 4y by itself. So 4y will equal 68. Divide by 4, 68 divided by 4, and that will give us 17. So y is also 17 on this one. So both x and y are the same number. Okay, so we're almost done. There's just one more thing that I wanted to discuss and show you, and that was the core concept there back on page 208. It says ways to prove a quadrilateral is a parallelogram, and so here is 5 ways that we can prove that a quadrilateral is a parallelogram. We need to know these 5 ways, so these are the theorems that you need to know. We can do number 1, show that both pairs of opposite sides are parallel, and that's the definition of a parallelogram. So if we just know that both pairs of opposite sides are parallel, that's definitely a parallelogram. We can also show that both pairs of opposite sides are congruent. That's another way we can do it as well. Show that both pairs of opposite angles are congruent. Okay, and those were the parallelogram opposite sides or opposite angles converse theorems. We can also show that one pair of opposite sides are congruent and parallel. So that would also be another way. And number 5, we can show that the diagonals bisect each other. So that was that parallelogram diagonals converse. So these are the 5 ways that we need to know that we can show, that definitely show that a parallelogram, or that a quadrilateral is a parallelogram. So a 4-sided figure, which is called a quadrilateral, is a parallelogram. All right, so that concludes our lesson for 7.3, and I'll see you in class.